Okay, welcome to this next video with regards to the topics which we're continuing on relationships. Okay, so in the last one we talked about slope, and in this one I want to talk about the connection between slope and rate and how that rate changes. Now, slope is great, and we defined it as basically the steepness of the line. And I can do a link up above for you if you've missed that one, so you can watch it before this. But now with these slopes, we do want to connect it to something in the real world. And that connection actually comes through understanding rates. Now, rate is a very difficult topic to try to explain, especially if you're just starting off. Once you understand the concept of rates, then obviously it's much easier. But if you're not familiar with them, it's not that easy actually to try to explain. So I'm going to try to do my best through some examples and then connect it and show you how rates are basically just a connection with slopes. So on the screen, what you see kind of three different examples, and I try to put some basic examples of rates. Now, if you're technically thinking about rates and you had to define it, then it is basically the comparison of two different quantities. So you're comparing two different quantities. Maybe you're comparing the amount of money to time. Maybe you're comparing the amount of distance to time, or maybe you're comparing some other two quantities. Now, very often, especially in the beginning, as you're learning these, time will have some connection to some other quantity. Now here, what we have is, I'll try to explain these three particular rates and then kind of break them down to you. Okay, so what we have is, we have a rate, and the first rate states that every 2 hours you make $50. And what I want to highlight here is because rates deal with two quantities. So now quantities are typically measured in some way, and then we associate different units with those quantities. So now in this case, you have every 2 hours you're making $50. So what are the quantities, or the two quantities that we're trying to connect? Well, 2 hours is basically time, and $50 is just the amount of money. So those are two things that we can measure, and that's what a quantity is. We can put a number on it, and typically it comes with some unit. So what we have here is, we have, okay, the first rate is basically a comparison of time, and that is compared to the amount of money. And I'll just put money here instead of just writing amount. So we have those two nice quantities as a comparison between each other. And we know that every 2 hours we would make $50. In the second example, it says you cover 40 kilometers in 80 minutes. So again, the rate is a comparison between two different quantities. And in here, we have our measurements of 40 kilometers and then 80 minutes. So the 40 kilometers represents distance of some type, or maybe some height. So that is the distance, and we are comparing it to time. So those are the two quantities that we are comparing. And it's just telling us a rate. So basically, how quickly we're covering the distance and how long it takes us. The last example that you see there on the screen, it says you have 20 milliliters of medication flows in 10 minutes. So maybe you're using some kind of an IV, okay, at a hospital. And what it's telling us, we have this 20 milliliters, which basically flows out, and you can imagine, out of the IV. And then it takes about 10 minutes to do that. So here the quantities are, so the 20 milliliters is basically volume, and we are comparing that volume, okay, with time. So that's the first thing that you should note about a rate. A rate is a comparison between two different quantities. That's what we have there. And what we like to do is we typically like to represent these rates in mathematics or in science kind of as a little bit of a ratio. And you may remember that for ratios we sometimes use these double dots, but we can also use the fraction form of a ratio. Okay, so for example, every 2 hours you make $50. I can represent this by simply writing, so $50, okay, you can represent it like this, okay, if it was a ratio, or you can represent it like this in fractional form, okay, and this would be for every 2 hours. So that would be now more looking like a rate just in a fractional form. And notice the key thing here is what we have units, and those units are, one is a unit on top and then one is a unit at the bottom. So we have two different units here. Now in the second one, when we're comparing distance and time in terms of rates, so what we have there is we have 40 kilometers in 80 minutes. So I could write this as 40 kilometers, okay, and then in 80 minutes, so this would look something like this. Or I can write it as a fraction form, and it would look something like this. And that is also a rate. So this is a rate, and now this is a rate where you're comparing two things. And then the last one, okay, if we had the 20 milliliters in 10 minutes, so I can write it like this as just a regular ratio, or I can write it like this, which is 20 milliliters all over 10 minutes. Now, these examples bring about, and especially as you write them in fractional form, the concept of slope. Because if you may remember, slope was just the rise over run of a line. So we had rise, which was on top, and then run, which was at the bottom. And we designated that particular slope, and we said that slope, which was designated as m, was equal to rise all over, so divided by the run. Right? And it was the change, okay, of how quickly you're moving up and then you're going across. And that was in that video with regards to slopes. So now notice that all of these, so if I take any of them, so for instance, if I take this looks exactly in that format. Let me just change this back here. So this looks exactly in that format. So it looks like we have $50, which would be your rise, and then your run would basically be for 2 hours. Now, when you're talking about a slope, because it's general, we don't know what the quantities are, so we just use X and Y all the time. But in this case, okay, we would be using money, and then we'd be comparing it in terms of time. And we can also graph this, right? We can actually graph it on a line, okay, or on a XY coordinate, okay, and then our XY coordinates would change so that we can easily see what happens. So let's do that so that you can see that it relates directly, basically, to a slope. So if I take this right here, and I am going to change this a little bit here, because I don't really need the negative coordinates here because we're making money, okay, so it's positive. Now, if I take this, notice that originally what we had is we would put our X right here, and then our Y would be on the vertical axis. But now what we have and what we're dealing with is we're dealing with money, okay, so money would be on this axis, and then we have time, which would be on these axes, and that's coming from right here. So in terms of graphing, I can graph this and put the time there. So for instance, if we would have this, and I'm going to just skip, so this is 1, this would be 2 hours, and this is all in hours here, so let's put that in brackets, and then 3, 4 hours, 5, 6 hours, 8 hours, and so on. And in terms of money, what I can do is, okay, so I can label these, and I can represent them kind of in, let's say, if I put this at $50, and then we would put this at $100, so I'm just moving up by basically $50 on each of those dashes that we have. So if I graph this and I know that for every 2 hours I am making $50, so that means my first point would be right here, right? For the first 2 hours I would make $50. Now if I continued, let's say, maybe if I was working, then I would notice that, well, for the next 2 hours, okay, I would make another $50. So in total I would have $100, and I would have that, and then this would be just labeled in this way. And notice now I have my line, and I can connect these through, okay, and this would be a line which is kind of going in this direction, right? So that's what that would be. And again, so remember that your slope is your rise over run. So if I take, okay, my slope from any of these and let's say label it. So if I take, for instance, from this right here and then this right here, so what I have, okay, right there is, so this would be my rise and this would be my run. And if you notice, okay, what you will do there is, okay, if you find your rise over run and you calculate it, so in this case, my rise, so starting from 50, so basically I'm going from 50 all the way up, okay, to 200. So that rise is 150, that's my rise, divided by, okay, and now my run, so I'm running from 2 all the way to 8 right there. Okay, so 2 to 8 is basically 6. So I have, so this is dollars and this is hours. And you might say, oh, it doesn't really look like 50 over 2. But remember that if you simplify this, okay, so what you have is, so 50 divided by 2 is basically you're making $25 per every 1 hour. And if you take this right here, okay, and you simplify that, you're going to get exactly the same thing. This is basically $25 for every 1 hour. And that is your slope, and that is just simply the rate, okay, of change, okay, of that particular comparison between money and time. And you can do that to all of these different things. So if we took, for instance, this right here, now, of course, I can simplify 40 kilometers in 80 minutes. And what I would get is, okay, so if I do that, is I would get 1 kilometer. Okay, so this is, for instance, 1 over 2. Okay, so 1 kilometer for every 2 minutes. Okay, or in other ways, so if I would write 1 over 2, so that's basically 0.5 kilometers per every single minute. And now with rates, if your denominator that you have is basically 1, so for instance 0.5 kilometers per 1 minute or $25 per 1 hour, when it is per 1, we call that a unit rate. The word unit means 1 because it's per 1 unit. So rate just means a general rate, a comparison, and unit rate means that it's per 1. You've basically simplified it, and that is your actual slope that you have. So your slope turns out to be, okay, in simplified and reduced form, basically your unit rate. And that's what you would get, okay, anytime you would do these rates. Now, why do we call it a rate of change? We call it a rate of change because if you, for example, are working and every 2 hours you make $50, well, if you work more than 2 hours, then the amount of money you make changes, right? Depending on how much you make. So that's why we call it a change. The same thing would happen to any of the other examples. If I take the third example and I have 20 milliliters of medication which flows in 10 minutes. So now if it flows for 15 minutes, then the amount of medication would change, so that we call it a rate of change, where it's a comparison between two things. So these rates of change are basically just slopes when you start graphing them on an actual x and y coordinate, or whichever two quantities that you are using. All right, so I'm going to end the video here. And I hope that you do see the comparison and match between what is a rate, which is basically a comparison between two different quantities, and then a slope. And you should see that they're basically aligned, that a slope and a rate are basically the same type of thing. All right. Okay, so thanks for watching, and we'll see you in a future video. Bye, everybody.